Welcome to the third part of the series, where we will explore two different ways to manually scrape data via our Jupyter Notebook, clean and combine it, and more. Here we will try to create a more robust dataset about data related to the film industry compared to the one downloaded from Kaggle in the previous video. Box Office Mojo is a well-known site that has been around for a long time and is also an official part of IMDb. When looking at worldwide box office results, they appear to provide data going back to 1977. For 1977, there were only 40 results. Let us check how things look for the current year. It appears at some point in the timeline, the tables were extended to 200 records. Now these are two links that can be saved for use in our Python script. OMDb API is a free RESTful web service containing more comprehensive metadata related to films. This will give us additional features on top of those from Box Office Mojo. It is first necessary to request an API key from them. It is free, but there is a limit to 1,000 free daily requests. Copy the API key they send via email so that it can be used in the Jupyter Notebook. Now let's get to the Jupyter Notebook. You can open the command prompt by pressing the Windows key and typing CMD, then pressing Enter. Then activate your Python virtual environment and type Jupyter Lab, then press Enter. We'll first start a fresh notebook and rename it to Jupyter 3. Then we will do the initial imports of requests to help download the web pages, pandas to label and organize the data, time for spacing out the requests to be friendly to the host servers, and then BeautifulSoup in order to make sense of the web pages downloaded and search in the HTML for the tables before pandas starts handling it. First, the base URL is needed in which the range of years will be inputted. This next cell has the bulk of the code, starting with the list of years used as the input derived from the range function. The main scrapping is being done by the for loop that is looping through the list of years. Each loop plugs the year from the list into the base URL, puts in a request to download the page, BeautifulSoup then parses it and finds the table. Then time is used to pause the loop briefly before the next request. The loops also contain a print statement to help keep track of progress as well. The next cell being prepared will have the table's original column names written to be used for the creation of the pandas data frame. Once done scraping, the next cell can be executed for the data frame, then a new cell will call the head function to see how it came out. .info will also provide some overview. Here it shows that there are 9,252 records without any nulls. Once that is confirmed, the data frame can be exported as a CSV file. Opening the file in Google Sheets and exploring it a bit, it appears the first scraping of data from Box Office Mojo was a success. The next part of scraping data from OMDb will be a bit more complicated, but not by much. Let's start with a fresh notebook again and rename it to Jupyter 3.2. The same imports that were used from before will first be called in. Then the dataset that was just scraped via Box Office Mojo will be brought in as a data frame, following by the importing of Pickle and OS. Pickle saves the complex data that was scraped on your computer, preserving it and preventing rescraping. OS handles file paths and helps look for existing files, if any. The script is ready. It will take the data frame just scraped and consisting of over 9,000 records and pull a block of just 1,000 records from it, correlating to each request from OMDb. A quick check is being done before scraping to ensure that the base dataset that will be split into sections got imported correctly. This script appears to run smoothly until the end when trying to merge the new data frame with the subset of data from the Box Office Mojo data frame. Once the minor issue of column titles not matching was fixed up, the script was able to run to its completion. The .info function shows that there are 1,000 records in this dataset and most of the columns are filled with values. The .head function gives a glimpse of the top 5 records from our dataset. The next day, once the free daily limit from OMDb has been reset, the script can be changed slightly and ran again in order to get the next section of the dataset filled. This time, the crucial last step of exporting the dataset as a CSV file can be seen at the end of the script after the initial checks of the new data frame are shown. Now we have another completed part of the dataset. Once we have all 10 blocks of data, we can then combine them as will be shown in the next video. Thank you for joining. Hope you enjoyed.